we go. Binomial expansion. Okay. If we want to FOIL out a binomial, okay, we do this occasionally. We usually only FOIL out 2 of them. So like if we have a binomial that's squared, we write it twice and then we FOIL it out. Y'all know we do that, right? That's the thing. Yes?
Yes.
Okay. We can do that pretty easily if the exponent is a 2. Okay, if the exponent's a 2, you just do a little, a plus b times a plus b, multiply it out. But if your exponent starts getting larger, it's going to be really tedious to do that. So like if your exponent was a 10, it would be really annoying to have to do a plus b times itself 10 times. Okay, think about what that would entail. So because of that, we have a method called the binomial expansion theorem to help us expand binomials. And that involves using Pascal's triangle. Anyone ever heard of Pascal's triangle? It's named after a mathematician. Guess what his last name was? Pascal. The first 5 rows of his special magic triangle are shown. We'll kind of talk about the pattern and then we'll complete the next 2 rows of it. Okay? So the very top one has a 1. And then every row underneath that starts with a 1, ends with a 1. 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 Does anyone see how they're getting the numbers in here, though? They're adding the 2 that are above it, right? To get this 4, they added this 1 and this 3. To get this 6, what did they add? The 3 and 3, right? To get this 2, what did they add? The 1 and 1, right? Let's do the next 2 rows, okay? So it's going to start with a 1, and it's going to end with a 1. Okay? Now to get the next number, I'm going to add the 2 that are right above it. So what number is going to be next? A 5. And then again, I'm going to add the 2 that are right above it. So my next number would be a 10, and then another 10, and then a 5, and then we end with a 1. Okay? We're going to do 1 more of those. Again, you could do this forever if you wanted to. You could just continue on to a big giant mountain. But the next one, we're going to again start with a 1, end with a 1. Okay. My next term after the 1, I'm going to add the 2 numbers above it to get a 6. Good. And then we'll add the 2 above it to get a 15. And then we'll add the 2 to get 20. And then we'll add the 2 to get 15. And then add the 2 to get 6. Again, you could continue it on if you want to. Just it's tedious to do it. The numbers in Pascal's triangle, he actually figured out that these numbers actually represent the coefficients on a binomial expansion. Imagine that. How odd. And they did a lot of weird things with math back in the day. They had a lot of free time. They didn't have TV or phones, so they had to play around with math. It represents the coefficients when we expand a binomial like a plus b to some sort of power. Okay, let's just do a real basic one by hand. So we're going to do a plus b squared, which means we write out a plus b twice. And then we're going to do first times first. What would first times first be? A squared. Outer times outer would be a times b, which is just ab. Okay. Inner times inner would be another ab, which is a times b. And what would last times last be? B squared. And what happens to the 2 like terms in the middle? Combine them to make 2 ab's. So that would be a squared plus 2ab plus b squared. What are the coefficients of these numbers? 1, 2, and 1. Do you see that row in Pascal's triangle? Yeah, it's near the top. It's this one right here. 1, 2, and 1. Okay, let's hand multiply out 1 more. Okay, we're going to do a plus b to the 3rd power, which we already have 2 multiplied out, so we really just need to multiply it by a 3rd one. We need to do a plus b times the answer that we got before times this one, because this was 2 of them multiplied out. So that would be a squared plus 2ab plus b squared. Okay. So when we multiply this out, what we're doing is we're taking this a and distributing it, and then we're going to take the b and distribute it. Okay, if I do a times a squared, what's that going to be? A cubed, right? If I do a times 2ab, what's that going to be? 2a squared b, good. And then a times b squared would be just ab squared. Okay. And then I'm going to do the same thing. I'm going to take the b and distribute it. We'll have b times a squared. B times a squared. Remember, we usually write the a first, so I would write that as a squared b. Okay. And then we'll do b times 2ab. B times 2ab. 2ab squared. 2ab squared. And then b times b squared would be b cubed. Okay. Looking through this, did I have any like terms? I definitely see there's the a squared b here and a squared b here. And there's also this ab squared and this ab squared. So we can put those together. So my final answer, I'm going to have an a to the third power at the beginning. And then I'm going to have a 2ab squared plus another ab squared, which makes how many ab squareds? 3ab squareds. Okay, 3. Actually, that was a squared b's. A squared b. And then we have ab squared plus 2ab squared, which would make 3 of those ab squareds. 3ab squared. And then what's at the end? B cubed. Okay. And then just looking at the coefficients of these terms. What was the coefficient of the first one? 1. And then we got 3, 3, 1. Do y'all see that row? You see it in the Pascal's triangle? Do we see that row? 1, 3, 3, 1? Okay. So when we do expansions, okay, we really need to pay attention to what the exponent is, because the exponent helps me figure out what row I need to look at in my Pascal's triangle. Okay. So when the exponent was 2, those numbers came from which row? The third row, right? When the exponent was 3, those numbers came from the fourth row. So we'll be always looking at whatever the exponent is plus 1, the n plus 1th line. So like if the exponent's 5, you'll look at the 6th row, 5 plus 1, 6. Okay. All right, looking at the first one that we're actually going to do, and we're not going to do it by multiplying 5 of them out. We're actually just going to follow Pascal's triangle rule, and I'll kind of show you how to do that. It follows a neat little pattern. Okay, so if the exponent is 5, what row are we going to look at? The 6th row. Okay, so let's see. 1, 2, 3, 4, 5, 6. That's these numbers. 1, 5, 10, 10, 5, 1. So what I want us to do, I want us to write out those numbers, but we're also going to leave some space in between them. We're going to write out 1, leave some space, 5, leave some space, 10, leave some space, 10, again, leave some space, 5, leave some space, 1, because we also have to adjust our variables. So here's the pattern that the variables follow. You're going to take your first term here, okay, which is just an x, and you're going to write x with the exponent that you see in the problem. So we're going to write x to the 5th power. And then for each term after that, the exponent just goes down. So the next term would have an x to the 4th power. And then the one after that would have an x to the 3rd power. And then an x squared, an x to the 1st. And then the last one would actually have an x to the 0, which we'll talk about in a second what x to the 0 means. You probably know what it means. Now, then we're going to take the second term of our binomial, which this one is a y. And it's going to start with 0 exponent and work its way up. Okay, so the y starts with a 0 exponent, and then the next one will have a y to the 1st power, and then a y squared, and then a y cubed, and then a y to the 4th, and then at the end a y to the 5th. In between all of these is going to be some adding. And then last thing I'm going to do is I'm just going to go through and simplify any that I can. Okay, so starting with the first one, we have 1 x to the 5th times y to the 0. And we know anything to the 0 power is just 1. So that you could really just write as times 1. So what would 1 times x to the 5th times 1 become? Just x to the 5th. Okay. And then we'll have plus 5x to the 4th, y to the 1st. Which of those exponents do we not normally write? We don't usually write a 1, right? If you want to keep it there, you can, but usually it would just be written as 5x to the 4th y. It doesn't look like anything simplifies on the next one, so I'm just going to keep it 10x cubed y squared. Same thing with the fourth one, 10x squared y cubed, no simplifying. What's the only thing we could simplify on the second to last one? Maybe just don't write the 1. Yeah, about it. Plus 5xy to the fourth. And then the very last term, we already talked about it. Anything to the 0 power would just be times 1. So 1 times 1 times y to the fifth is just y to the fifth. There it is, expanded. Now, sometimes the coefficients of these are not going to stay the same as what they originally were when we wrote them down. And that happens when one of your terms happens to be a number. And so one of your terms is a number. Obviously, that number is going to get multiplied in whenever we multiply it by the numbers in our Pascal's triangle. And we'll see that on this one. This one does have a number for one of the terms. Okay, if my exponent is 4, what row am I going to look at on my Pascal triangle? The fifth row. Get the fifth row. So I'm going to go look at the fifth row, and I'm going to write down those numbers from the fifth row. So we have 1, 2, 3, 4. Here's my fifth row. 1, 4, 6, 4, 1. So I'm going to write those down and leave some space in between them. 1, 4, 6, 4, 1. 1, leave some space, 4, leave some space, 6, leave some space, 4, leave some space, 1. And remember what we're doing. We're going to start with the first term of our binomial, which is an x, and we're going to write it with the highest exponent, which is the one we see in the problem here, which would be a 4. So it would have an x to the fourth, and then it's going to start working its way down. What would the next one be? X cubed, and then we got x squared, and then we got x to the first, and then lastly we'll have x to the 0, which we already talked about will turn into a 1, but I like to write it just so everybody sees it. And then we'll take the second term of our binomial, which is a 3, not a variable on this one, just a 3, and it's going to start with which exponent? 0. So we'll have a 3 to the 0 power. And then we'll start working its way up. Then we'll have a 3 to the first power. And then a 3 squared. And then a 3 to the third power. And then lastly, the final exponent should match the one that's in the exponent in the problem. 3 to the fourth power. To the fourth power. Okay, and then I'm just going to go through and simplify. Okay, remember you do have some adding in between here. All right, we got 1 times x to the fourth times 3 to the 0, which we know 3 to the 0 is equal to just a times 1. So what is all that going to simplify to? 1 times x to the fourth times 1 becomes x to the fourth. Jenny, lift your head. Manas, lift your head. Okay. And then we have a 4 times an x to the third power times a 3 to the first power. What's 3 to the first power? 3. And we multiply it by this 4, what are we going to get? A 12. So we'll have 12x cubed. Okay, on the next one, we have a 6 and a 3 squared. What would 6 and 3 squared multiply to? Everybody's got a calculator. Feel free to grab one if needed. 6 times 3 is 54, right? Because that's just 6 times 9. So 54x squared. And then we'll have a 4 times a 3 to the third power. So that's 4 times 27, which is 108. Good job. Also, do I need to write that exponent on the x? Nope. And then last up, we have a 1 times an x to the 0, which would also be a times a 1, times a 3 to the fourth power. 1 times 3 to the fourth is 81. So you'll notice that it no longer matches what the original coefficients from the Pascal's triangle was, and that's just because of that 3 got multiplied into it. All right, 2x plus 1 to the fifth, what row are we looking at on our triangle? The sixth row. I believe we've used one from the sixth row before. 1, 2, 3, 4, 5, 6. Yep, it was 1, 5, 10, 10, 5, 1. 1, 5, 10. Make sure you leave some space. 1, 5, 10. 10, 5, 1. All right. We're going to take the first term. Now, the first term actually has two factors. So I am going to need to write that in parentheses because it has a 2 and an x. And it's going to start with which exponent? What exponent is going to start with? Everyone looking at me, what exponent will it start with? It does not start with a 2. It starts with what exponent? A 5. Why a 5? That's the one in the problem, right? So we'll have 2x in parentheses to the 5th power. And then what's the next one going to be? 2x in parentheses to the 4th power. And then 2x in parentheses to the 3rd power. Just working our way down. Okay. And then we'll take the second term. What number is our second term? It's a 1, and it's going to start with which exponent for the first term? 0, right. So we'll have a 1 to the 0, and then we'll work our way up. 1 to the 1st power, 1 to the 2nd power, 1 to the 3rd power, 1 to the 4th power, and 1 to the 5th power. Okay, now I know this one looks a little more complicated, so I'm just going to kind of go one term at a time to not overwhelm us. Starting with the first term, okay? I do have a 1, and I've also got a 1 to the 0, which is just 1. But then I need to be careful with that 2 to the 5th power, because not only do I need to do 2 to the 5th power, but I also need to do x to the 5th power. 2 to the 5th and an x to the 5th. So I've got a 1 and a 1 and a 2 to the 5th and an x to the 5th. What's 2 to the 5th power going to turn into? 32. So all together, this would multiply to what? 32x to the 5th. All right. Okay. Looking at the next one, I have a 5 and I have a 1. And then that 4 needs to go to both the 2 to the 4th, and x to the 4th. Okay, so when you multiply, you have a 5 that you need to multiply, you have a 1 you need to multiply, and you have a 2 to the 4th you need to multiply. All of those multiplied together would be 80. And then what variable do I have? X to the 4th. Okay. Okay. Looking next, we have a 10. We have a 1 squared, which is just 1. And we have a 2 to the 3rd and an x to the 3rd. So we got 10 times 2 to the 3rd times 1 times x to the 3rd. What is that going to become? 80. Good. And what variable? X cubed. Okay, next up we've got a 10 again, a 1 to the 3rd, which is just 1. And then remember that square goes on both the 2 and the x. 2 squared, x squared. What's that going to all multiply to? 40, yeah. 40, and then what variable? X squared. Good. Okay. Next up we have a 5, we have a 1 to the 4th, and we have a 2 to the 1st and an x to the 1st, which 2 to the 1st is just 2. X to the 1st is just x. What's all that going to multiply to? 10, right. 10 along with what variable? 10x, very good. And then one last term. We have a 1. We have a 2x to the 0, which would become 1, just times 1. Times 1 to the 5th, all multiplied together, that's going to give you? Everyone together, it's going to give me a 1. All right, this next one. Notice every answer we've had so far has had plus signs in between. Plus, 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 plus. This next one is the first one that has a minus. Okay? So we're really going to have to use that. That is a -3 that we'll be working with. So our first term is 2a. Our second term is a -3. And that's going to affect the signs on all of our terms. If my exponent is 4, what row of my Pascal's triangle am I looking at? the fifth row. I believe we used those numbers before. 1, 2, 3, 4, 5. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Okay, we're going to start with the first term. The first term has two factors, so make sure you're using parentheses. And it's going to start with which exponent? 4. Starts with a 4 and works its way down. Then we'll have 2a to the third power, 2a to the second power, 2a to the first power, and at the end we'll have 2a to the 0. Okay. Now remember that second term is not a 3. You're using it as a negative 3. So it's going to start with negative 3 to the what power? 0. Good. And then negative 3 to the first. Negative 3 squared. 0, 1, 2. Negative 3 to the third power. And then lastly, negative 3 to the fourth power, which should be the exponent that's here. And remember, these might not necessarily simplify to all plus signs. Some of them might end up being negative, so think about that whenever you're doing your signs. Again, because it is kind of overwhelming looking, I'm just going to start one at a time. Okay, I've got a 1. I've got a negative 3 to the 0, which is just a times 1. And I have a 2a to the fourth, which would be both 2 to the fourth and an a to the fourth. So we have 1 times 2 to the fourth times a to the fourth, which is 16 is the number. What's the variable? 16, a to the fourth. Good. Okay. Next up, I have a 4. I have a negative 3 to the first power, which would be just a times negative 3. And then you have a 2 to the third times an a to the third. So on the calculator, we need to do a 4. We need to do times 2 to the third and times negative 3. 4 times 2 to the third times negative 3 ends up being not 24. Try again. 4 times 2 to the third times negative 3. Not 96. Negative 96. Negative 96. And then what's my variable? A to the third. Okay. Next up, I have a 6. I have a negative 3 squared. What's negative 3 squared going to be? What is negative 3 squared? It's 9, right? So you'd have a 6 times a 9 times a 2 squared times an a squared. So 6 times 2 squared times 9 times a squared, what do we get? 6 times 2 squared times 9. 216, and then what's the variable? A squared. Good. Okay. Looking at the next one, I've got a negative 3 to the third power. I have a 4, and then I have 2a to the first, which would just be 2 to the first times a to the first, or just 2 times a. Make sure when you do negative 3 to the third power that you're doing that base in parentheses. Anytime you have a negative base on the calculator, always use parentheses. So we need to do a 4 times a 2 times a negative 3 to the third power, and we get, some of y'all need to type in. Some of y'all just relying on other people to get your answers. Negative 216. And then what's our variable? Just the a. Good. And then one last term, we've got a 1. We have a 2a to the 0, which would turn into anything to the 0. It's 1. And then we have a negative 3 to the fourth power. Remember, when you type that in the calculator, you have to use parentheses. It will give you the wrong answer if you don't. 81. Yep. All right. The practice SAT question is not only a binomial expansion, but it also is kind of one of those SAT symbol problems. where they just give you a symbol, but then it doesn't actually really affect. It says for all real numbers m and n, m heart n is the same as doing m minus 4n to the third power. And then it just says how else could this operation be defined? So again, it's asking, it gives you as an SAT symbol problem, but it's not asking you to do anything different than what we just did. It's asking you to expand that binomial. What row of Pascal's triangles should you be looking at? Fourth row. Okay. Fourth row is going to be what numbers? 1, 3, 3, 1. Now, does that necessarily mean my final answer should have the numbers 1, 3, 3, 1 in it? No, they might change because we do have a number in here. Okay. I'm going to give you guys, let's see if we can get this one knocked out in about 2 minutes, trying to figure out what that final answer would be, working with our group, getting it set up, simplified. Calculators on your desk if you need them. For the first term of the binomial starts with the highest exponent. Second term of the binomial starts with the lowest exponent, which would be a 0. Once you get a few of the terms simplified, you might be able to narrow down your answer and find it. But sometimes if you look at them, they all have different numbers for the second term. So if you could simplify that second term, you might be able to find it. All right, let's look at it. Okay. So I've got my first term m to the third, and then I just work my way down, m squared, m to the first, m to the 0. And then my second term is negative 4n. So negative 4n is going to start with a 0, and then go to the first power, and then go to the second power, and then go to the third power. Again, they all have the same first term, so my first term is definitely m to the third power, but that second term is where we're going to be able to narrow down the answer choices, because we'll have a 3 times an m squared times a negative 4 to the first and n to the first, which will be 3 times negative 4, which is negative 12 m squared n, making it the fourth answer.